Hey guys, it's Mitchell and we're doing another one of these gold papers. This is the first one that I'm actually doing for foundation. So I did one for the grade 9, this is for foundation. I'm going to link the other foundation papers that I've done in the description. These are all aiming for grade 5 questions. So if you really want to get that grade 5 in your exam this year or next year, whenever you're doing it, it'd be really good to look at these aiming for grade 5 papers because they contain some of the hardest questions that you can get asked in foundation. Again, not all of them are grade 5, but they are the hardest versions of each question that you can get, if that makes sense. So I'm going to walk through the exact thought processes that I do whenever I approach any question, which will help you then build up an understanding of how to really decode the question. What's the question asking you to do? What are the steps? Because a lot of students know the steps when I tell them what the steps are, but they can't actually figure out the steps on their own, which is what I aim to help you with here. So without further ado, let's jump straight in. So here we're starting off with another one of those questions that is, it's a bit confusing to a degree. So it says there are 5 grams of fibre per 100 grams of bread. And then each loaf of bread has a weight of 400 grams. There are 10 slices of bread in a loaf. Each slice of bread has the same weight. Work out the weight of fibre in one slice of bread. So here, again, what I would personally do is I'd follow the dice strategy, which I will talk to in a second, but I'd also kind of work out or just highlight exactly what they want. So we want to work out how much fibre is in a single slice of bread. Now, bear with me, but with the dice strategy, it follows, well, obviously it spells dice, but the D just stands for diagram. So maths is actually extremely visual. If you can draw a diagram illustrating what you need to do, it'll make your life easier. Now, in my loaf of bread, what I'm going to do is I'm going to draw it as a rectangle. Okay? And that rectangle will weigh 400 grams. And it has 10 slices, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that going to be 10? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. So that is 10 slices. Perfect. And we need to work out the weight of fibre in this single slice of bread over here. Now, the other piece of information they give us is that there's 5 grams. In fact, I'm just going to put 5g for 100 grams of bread. Okay, so there's 5 grams of fibre for 100 grams of bread. Well, here's what I would do. We want to work out the weight of fibre in one slice of bread, so it would be useful to know how much fibre is in this entire loaf of bread. So how many grams do we have? We have 400 grams of bread. What do I times 100 by to get to 400? I multiply it by 4. So what am I going to do with the 5? You do the exact same thing to keep it in proportion. So 5 times 4 means there's 20 grams of fibre in this entire loaf of bread. Cool. Now, there are 10 slices of bread in this loaf of bread. So those 10 slices represent 20 grams of fibre. So once again, if I want one slice, well, how do I go from 10 to 1? I divide by 10. So I'm going to divide this side by 10. And that means in one slice of bread, there is 2 grams of fibre. So I'm just going to put the number 2 there for 3 marks. So in terms of the dice strategy, the D was for diagram, which is where we drew a very accurate picture of a loaf of bread. The I is identify. So this consists of a few different things. One, what does the question want you to do? So that's when I underline this. And what information does it give you? That's when I wrote this 5 grams of fibre equals 100 grams of bread, because that's the information they've given me. I've also been given how much bread we actually have, 400 grams. And technically I also know that there's 10 slices of bread. The C stands for calculate. That's when we actually start doing, the multiplying by 4, the dividing by 10, multiplying by 4 and all that stuff. Now the E is for evaluate. Now this is an interesting step because it encompasses a lot. 1, have we got the correct units? Well, in this question they gave me the units. 2, does my answer make sense? Well, if there's 5 grams for 100 grams of bread, and we're only talking about a single slice weighs less than 100 grams, so our number's less than it makes some amount of sense in that regard. But that dice strategy is what I'm going to try and use as much as possible. Remember, in maths, they do tend to give you a diagram. So the D step you can sometimes skip or at least just add to the diagram. So, as I said, the D part has already been done. The diagram has been written. So I, for identify, what do we want to do? Well, let's read the question. We have a right-angled triangle, and we've been given all three angles, technically speaking. And it says, work out the size of the smallest angle of this triangle. So we need to work out, so I've identified we need to work out the smallest angle. I don't know which one it's going to be, right? I don't know from looking at this which one's the smallest. What have they given me? They've given me a bunch of algebra and technically this shape here. They've also told me it's a triangle. Okay? So in order for me to know what the smallest angle of the triangle is, here's where I need to take a logical step. I need to know what each of these angles is worth. So what does 7x actually mean? What is that number going to be? Is it going to be 70? Is it going to be 140? What's it going to be? So that is where I now identify the calculation I have to make. Now, this isn't the calculation just yet. The I part is identify. Well, what information have they given me? The only information I haven't used yet is the triangle bit. What do the angles in a triangle add up to? They add to 180 degrees. So if I add these three angles together, I should get 180. So let's do that. We've got 7x plus 5x plus 18. Now, what is this little square inside the triangle? Well, it's a right-angled triangle. This actually represents a right angle, which is always worth 90 degrees. And that should all add up to 180 degrees. That is the end of the identify step, because we've identified what we need to do. We need to make an equation that we can solve in order to work out these angles. Now it's time for the calculate bit. So this is not a simplified equation yet. We need to add the x's together, the like terms. So 7x plus 5x, well, if I have 7 apples and I get 5 more, there's 12, so that's 12x. 18 plus 90 is 108, equals 180. Solving this, there's a few different strategies you can use. One of the ways is the balancing equations method, where you look and you subtract 108 from both sides, which will give you 12x equals 72. And then you know you need to divide both sides by 12, because 12x means 12 times x. We're doing the opposite. And you get x is equal to 6 degrees. Another way to do that, which I actually quite like, is writing it out as like a flowchart. So we have this number x. What's the first thing that happens to it? Well, the first thing is it gets times by 12. What's the next thing that happens to it? Well, it gets added by 108. And that gives me the answer of 180. So all we need to do is follow those steps in reverse. What's the opposite of adding 108? Well, it's taking away 108, which gives me the answer of 72. What's the opposite of timesing by 12? Well, it's dividing by 12. So I get 6. So x still equals 6. No matter which way you do it, it equals 6. This method really helps, but if you look, I did do those steps, right? I subtracted by 108 first in this step, and then I divided by 12. It's just a way of visualizing it. Again, it's another diagram we can use to help us. So now, working out the size of the smallest angle, well, you might be able to look at this and see what the smallest angle is. So 90 degrees, well, what's 7 times 6? Well, 7 times 6 is 42 degrees. So it's definitely not this angle that's the smallest. Okay, well, what's 5 times 6? 5 times 6 is 30. Add 18 would be 48 degrees. So the size of the smallest angle is 7 times 6, which is, as you put up here, 42 degrees. And that will be your final answer. So again, there's no way to know which one's the smallest one without actually working out the size of the angles. Don't forget, you can't look at it and say, oh, this looks smallest, because the diagrams are not drawn to scale. Exchange rate questions. So 3 companies sell the same type of furniture. The price of the furniture in London is £1,480. In Paris, it's €1,980. And in New York, it's $2,250. Which company sells this furniture at the lowest price? So we can't compare them yet because they're all different units. They're different currencies. And if you've traveled the world a little bit, you'll know that, a euro is worth a different amount than a pound, and a dollar's worth a different amount than both of them. So we need to convert them all to the same currency. And if I have a look here, we have the exchange rates. A pound is 1.34 euros. A pound is $1.52. So the only one that's in common is the pound. So what we want to do is convert everything to pounds. So let's start with the Paris. So we have 1,980 euros. I'm not really good at drawing the euro symbol, to be honest. But how do I change this into pounds? Well, here's the way I like to think of it. When you have these exchange rates, so I'm going to write the exchange rate just a bit bigger down here, just so I can make my point a bit clearer. If you're going from left to right, you always multiply by whatever the exchange rate is. So in this case, 1.34. But if you're going in the opposite direction, you always divide by whatever the exchange rate is. So here, am I going from pounds to euros or euros to pounds? I'm going from euros to pounds, so I'm going in the opposite direction. So I'm going to divide by 1.34. This is a calculator question, or at least I'm making it now. So 1980 divided by 1.34 will give me an ugly number, 1477. And again, we're rounding it to 2 decimal places because you've never seen a price tag that has 0.61194 on it. So we always round it to the nearest penny. 1477.61, like so. So at the moment, that is actually cheaper than London. So this one is looking pretty good. Now with the dollars, it would be a good idea for you guys to maybe pause the video for a second and just ask yourself what you would do. Would you times by the exchange rate, or would you divide by it? So again, pause just for a second while I write out, or just wait while I write out this, have a think. So again, going with it, we're going to times, going against it, we're going to divide. So we're going in the opposite direction back to pounds, so we're going to again divide by $1.52. So again, get our calculators out. So 2250 divided by $1.52 gives me probably another ugly number, 1480.26. Oops. So it looks like the New York was the most expensive and Paris was actually the cheapest. Interesting. So the company that sells the furniture was Jardins from Paris. So let's write that, Jardins of Paris. And again, that's why they want you working out, okay? These exchange rate, this is all the working out you need. So you literally just get a mark for each of these, and then for your actual conclusion, which is which company is actually the cheapest. If you do that, you get the full 3 marks. Probability is probably the worst topic in maths, especially within the foundation paper. So here we have red, blue, green, and yellow counters, and those are the only counters in the bag. The table shows the probability of picking at random a red counter and picking at random a yellow counter. The probability of picking a blue one is the same as picking a green one. Complete the table. Well, here's a few things. First of all, the reason why they tell you there's only these is because it means that all of these probabilities should add up to 1. That's what it should do. But next thing I want to go through is, what does this mean? The probability of picking a blue is the same as picking a green. Well, what does that mean? Well, if I have this counter, this bag of counters, it's more like a flask, but whatever, where I have, let's say, 2 blues and let's say 3 greens, I don't know, for an example. How do you work out the probability of getting a blue? Well, what you do is you take the number of blues over the total number of counters. And then for green, that would be 3 over 5. So the only way for them to have the same probability is if there's the same number of blue and green counters. In other words, when we work out what's left over, so that's what I'm going to do, is I'm going to work out how much probability is left over. So 0.24 add 0.32 is 0.56. Then I'm going to do 1, take away 0.56, that's not a 6, is equal to 0.44. That is blue and green added together. But because they have the same probability, all we have to do is divide it by 2. And then that will give us our answer. So that gives me an answer of 0.22. So there and there. Okay, so you can remember probabilities always add up to 1, and if they have the same probability, you can just half whatever the answer is, and it's equal. The pattern is made using identical rectangular tiles, not triangles. Find the total area of the pattern. So again, identifying the kind of key points here is these are identical. So that means each of these rectangles is exactly the same size. Now if you want to work out the area of the pattern, can you see all you would have to do is find the area of one rectangle and multiply it by 1, 2, 3, 4. So it's just 4 times the area of one rectangle. Sounds easy, right? Well, is it though? Because how do you work out the area of a rectangle? Well, what you do is you take its width and you times it by its length, right? If you look carefully, I actually don't know either of those numbers, right? Like the length isn't 7 because this is the length of one rectangle. It's a length plus a width, right? So we know that a length plus a width equals 7, right? Because we have the length and we also have the width of the next rectangle. Okay, what about this 11 then? Well, that's a length plus another length plus a width. So in other words, that's 2 lengths, 2L, plus a width gives me 11. Interesting. So, what do we have here? We have 2 equations with 2 unknowns. 2 equations with 2 unknowns means it is a simultaneous equation because we have 2 equations with the same unknowns in both. So, we have to solve this simultaneous equation. Now, how do you do that? In fact, to make my life a bit easier, I'm actually going to swap these 2 equations around because I've noticed something. Well, all you need to do is make one of the letters, one of the variables, one of the unknowns, have the same coefficient. What's a coefficient? It's the number in front. What's the number in front of W? It's 1. What's the number in front of W? It's 1. What's the number in front of L? It's 2. What's the number in front of L? It's 1. So, can you see that W in both equations has the same number in front? The number 1. We don't write the number 1, but there is a 1 there. Now, all we do is we subtract the 2 equations because they have the same number in front and they're both adding. So remember, same sign, you would subtract it. So in this case, they're both adding, so we subtract it. But if there were different signs, so one was adding, one was subtracting, we would add them together. So if I subtract these two, I have 2L minus L is L. W minus W is nothing. 11 minus 7 is 4. So the length of one of these sides is 4 centimeters. Okay, now subbing that back into here, if L is 4 plus the W gives me 7, then W must be 3 centimeters. Well done. Now we know the dimensions of each of these tiles. So the area of one is just equal to 4 times 3, which is 12 centimeters squared. And then how many tiles did we have again? We had 1, 2, 3, 4. So that means the total area, and I would write this all out, make it nice and neat for the examiner. You may not like them, but at the end of the day, they're giving you a grade, so it's a good idea to keep them happy. So 48 centimeters squared for a big fat 4 marks. Again, hopefully you noticed the thought process. I identify what I need and how I can get it. And again, practicing this, I promise you will get easier over time. I didn't know how to do this always. It was trained. It happened over time. Practice makes perfect. These kind of problem-solving questions especially are really useful to improve your, problem-solving skills. I actually think this is quite an old question. I remember doing this in my GCSEs, or at least a question similar to it. So Becky has some marbles. Chris has 2 times as many as Becky. Dan has 7 more than Chris. In total, they have 57. Dan says, if I give some marbles to Becky, each of us have the same number of marbles. Is he correct? The answer to that is I don't know. This doesn't really mean much to me. So what would be really useful to know in order to be able to actually verify the statement? Well, it'd be really useful to know how many marbles each of them have. Now, I will say one thing, and this is really, really important, is some students will say, well, there's 57 marbles. Can you divide 57 by 3? You can. It's 19. And so they'll say, yes. But the key thing is, it's not saying, can they divide them all equally? It specifically says, if Dan gives marbles to Becky, they'll all have the same. So this is not the right approach, okay? Because that is, if they redistributed all of them. It's not that. Only Dan's giving up marbles. So it would be useful to know how many marbles each of them have. And don't forget, it's also a 3-mark question. It's not going to be as simple as 57 divided by 3. Yes. So, do I know how many any of them have? No, but I know how many they have in relation to each other. If Becky has some marbles and I don't know how many she has, why don't we just call that n for number of marbles? Well, now Chris has 2 times as many, so he has n times 2. He has 2n marbles. And Dan has 7 more than Chris, so that means 7 more means add, so it's 2n plus 7. And in total, what does total mean? It means you add all of them up. So if I add them all up, n plus 2n plus 2n plus 7 is 57. I should now be able to work out, well, again, just like we did in that the angle question, we can now work this out. So n plus 2n is 3n, plus another 2n is 5n, plus 7 is 57. Subtract 7 from both sides, we get 5n equals 50. Divide by 5, you get n equals 10. So now we can work out how many each person has. Becky has just n marbles, so she has 10. Who's the next person? Chris has twice as many, so Chris has 20. And lastly, it was Dan who has, Chris has 20, but 7 more, so he has 27. Okay. Cool. So now we can work out, can Dan, again, remember, Chris's marbles will not change. It says Dan, so Dan is saying I, so Dan gives marbles to Becky, each will have the same number. Well, that means they would all have to have 20 marbles, right? Because Chris's number isn't going to change. For Dan to get to 20, he has to give away 7. But if Dan gives 7 to Becky, she'll have 17, which is not the same. So no, because Dan cannot give Becky enough marbles. That's what the question's actually asking for. Now we have some written questions, which in a maths exam probably makes you feel a bit sick, but let's go. So 4 friends each throw a biased coin, so that means the probability of getting heads and tails is not the same. A number of times, the table shows the number of heads and tails each friend got. So, read through that. The coin is to be thrown 1 more time. Which of the 4 friends' results will give the best estimate for the probability that the coin will land heads? And here's where a lot of students would probably say, well, whoever has the most number of heads. Now, in this case, you would be right, but your justification would be wrong and you wouldn't get the mark. So, the answer is indeed Sheriff. But your justification needs to be very specific. It's not because you got the most number of heads. If I add these numbers up, this is the total number of times each of these people threw their coin. The reason why Sheriff is the best is because he threw his coin the most number of times. Remember, the more times you do this experiment, the more accurate your answer will be. In the same way that in science, when you repeat an experiment, it makes it more accurate. Right? If I do something once, let's say I flip a coin, I get heads, I can't say I'm guaranteed to get heads every time. In the same way that if I flip a coin twice and I get 2 heads, it doesn't mean that there's a 100% chance of getting heads. I just happen to get 2 heads. So you want to pick the one with the most number of, they call it trials, but in this case the number of throws. So because he has the most number of throws. Cool. Now it should be noted that they all throw the same coin. I'm just going to bear that in mind. But part B, Paul says, with this coin you're twice as likely to get heads as tails. Is he correct? justify your answer? Well, if I look at Paul, he does get twice as many heads as tails, but the others do not have that same relationship. So what I would say is it's true for Paul, because remember, it is all the same coin. For Paul, not for the rest. And lastly, the coin is to be thrown twice. Use all the results in the table to work out an estimate for the probability that the coin will land heads both times. So how would you do that? You'd find the probability of getting one head, and you times it by the probability of getting heads again. So it says use all of the results. So what we're going to do is we're going to add up all of the heads. So using our good old-fashioned calculator, we have 34 plus 66 plus 80 plus 120, because remember, it's the number of heads over the total number of throws. So that's 300 over the total number of throws, but it's a good thing I've already added them up. You would normally have to add up all of the numbers in here, but I've actually already added them up along the bottom. So what I can do something very fancy, and I can just go 42 plus 78 plus 120 plus 160, which is 400. You might notice that that just simplifies down to 3 over 4. But we're going to times it by itself, right? Because the probability of getting a heads won't change from throw to throw. So that is just, I'm not going to, I'm just going to write it out as I see it, but that is the same as just 3/4 times 3/4. But, let's let our... So technically you could have done that without a calculator, but you know what, it's fine, right? It's fine. Being a little bit lazy is okay from now and then. But that is the answer. Next question is the last question. Boy, do they give us a fun question to end on. We have a diagram, so again we don't need to do the D part, giving a rectangle and a circle. BC is the diameter of the circle. Calculate the percentage of the area that is shaded. Students hate this one. They hate it. So, what do I need? Identify. What do I need to know in order to work out the percentage of the area that's shaded? Well, what you need to do is you work out the shaded area. And if you also notice, they've been really bloody sneaky, work out the percentage of the area of the rectangle. So we're not actually including the area of this. This whole thing over here is obsolete. We don't need it at all. We're only looking at the area of the rectangle. Very sneaky. So it's over the area of the rectangle. That's what fraction of the area is shaded. How do you turn fractions to percentages? All you do is you times them by 100. So again, it's the shaded area over the area of the rectangle. And the area of the rectangle isn't too bad. We can identify how to work that out. It would just be 16 times 19. That bit I'm fine with. In fact, why don't we just work it out now while we're here? So bring our calculator over. 16 times 19 gives you 304 centimeters squared, although the unit actually won't matter in this case because it's going to be a percentage anyway. Shaded area though, this is where it gets a bit more fun. So if you look, the shaded area is a very bizarre shape, right? It's like mostly a rectangle, then it becomes a weird thing. So here's the trick. You work out the area of the rectangle, right? Which I am aware we've already worked out. And you subtract the area of this white thing inside of it. You subtract the area of the semicircle. So that is 304 subtract. Now how do you work out the area of a semicircle? Well, what's the area of a circle? It's pi r squared, right? Yeah? But this is a half of a circle. This is a semicircle. So all we do is we half it. Now, actually no, I'm not gonna write it like that. So what would the area of the semicircle be? Well, the radius of the circle. My apologies. Well, the diameter is 16, and remember the only difference between diameter and radius is that the radius is half of the diameter, so 8. So we're going to do, I'm going to put this all in my calculator in one step, minus a half, so let's put a half there, pi r squared, so 8 squared, and we're going to get 203.469. I am going to write out the whole thing, because now we're actually going to do the calculation for this. So 203.469 over 304 times 100 gives me something. Let's have a look. 203.469 over 304 multiplied by 100 gives me 66.9%. It says to one decimal place too, so that's lucky. 66.9%. For a full marker, it's conceptually difficult, but the actual amount of maths you have to do is not that much maths, right? It's not that much, right? So hopefully not too bad. Again, that brings us to the end of this paper. I would like your help though. Let me know if I went slow enough, or if I went too quick, or if I went too slow, or like whatever, just so I can adapt for the next one. If this video does decently well, I can do the other 3 papers. There's 3 more of these. But as I said, I've got the other Aiming for Grade 5 papers. Those are full-length papers, hour-and-a-half papers, in the description as well, if you want to have a look at those. But I'll leave the link to this paper if you'd like to have a go yourself, maybe in a week or half a week, just to see how much you've retained. But other than that, I hope you have a wonderful day.